January 14th, 1943. The dense tropical air of Guadalcanal hung heavy with heat and humidity. Palm fronds swayed gently, masking the distant thrum of artillery and the low hum of distant aircraft. Amid the shattered coral runways and charred remains of Japanese outposts, a small group of Japanese engineers moved cautiously. Their boots sank into the damp, red soil mud, leaving prints that would soon be erased by the relentless Pacific rains. In the center of the abandoned American base, a curious sight caught their attention. A compact, metal box humming quietly, its wires neatly bundled, a small engine idling smoothly despite days of tropical exposure. Portable, reliable, almost impossibly durable. The engineers exchanged uneasy glances, fingers tracing the lettering stamped into its casing. U.S. Army Portable Generator, 2 kilowatts. They had expected scavenged American equipment to be fragile, temperamental, difficult to repair. Instead, this small machine radiated a confidence that unsettled them. Communications, lighting, water purification, medical equipment, all could run independently, anywhere, without reliance on vast infrastructure. And in that moment, they realized that the Americans had solved a problem they themselves had long struggled with. It was a revelation that would echo through the islands. By early 1942, the Pacific War had reached a critical impasse. Japanese forces, flush with victories across Southeast Asia and the Western Pacific, controlled vast stretches of ocean and dozens of islands. Yet, their rapid expansion had come at a cost. Supply lines were overextended, and maintaining forward bases became increasingly difficult. Soldiers struggled with tropical diseases, inadequate food, and the constant threat of Allied air raids. For Japanese engineers and logisticians, each island presented a puzzle. How to keep communications running, fuel stored, water purified, and hospitals functioning under the relentless pressures of combat and climate. Meanwhile, the United States, still recovering from the shock of Pearl Harbor, had begun implementing an industrial and logistical strategy that would transform the Pacific theater. Unlike the Japanese, whose engineering was highly innovative but often resource-constrained, the Americans focused on standardization, mass production, and redundancy. Every piece of equipment was designed not only to function, but to function reliably under conditions that would cripple less considered designs. Engineers at factories in the continental United States had anticipated the difficulties of tropical warfare: humidity, salt corrosion, unpredictable terrain. Out of these calculations emerged a range of compact, durable, and transportable devices that could operate independently of conventional infrastructure. One of the most remarkable examples was the portable generator. Small enough to be carried on a jeep or landed by a small team of soldiers, these generators could produce sufficient electricity to power radios, lighting, water pumps, and even rudimentary medical equipment. In contrast, Japanese bases often relied on cumbersome diesel engines, which required specialized parts, constant maintenance, and a steady supply of fuel, luxuries that were increasingly scarce on isolated islands. The logistical contrast between the two forces became evident during the Guadalcanal campaign. American engineers arrived with prefabricated shelters, modular electrical systems, and portable generators. Within days, they established functional airstrips, fully lit bivouacs, and operational hospitals. Meanwhile, Japanese engineers struggled to maintain even basic electrical supply. Batteries ran dry, radios failed, and water pumps faltered. Every outage threatened not only operational capability, but the health and morale of troops isolated hundreds of miles from resupply. It was not only a technological disparity, but a philosophical one. Japanese engineering often emphasized ingenuity and adaptability, makeshift repairs, improvisation, and maximal use of available materials. American design prioritized reliability and forward planning, robust devices that could withstand abuse, redundancy built into every system, and modularity that allowed equipment to be quickly repaired or replaced. On paper, both approaches were valid. In practice, The Americans' focus on portability and durability would soon give them a decisive edge. By the time Japanese engineers first encountered captured portable generators, they had already begun to understand the scale of the challenge. American forces were not simply bringing soldiers and weapons. They were bringing the ability to sustain operations anywhere in the Pacific, independent of fragile infrastructure. This capability allowed the U.S. to build advanced bases on previously inhospitable islands, maintain uninterrupted communications, and coordinate air and naval operations with precision. For Japanese commanders, this was a growing source of frustration. They had expected American forces to be hampered by distance, terrain, and weather. Instead, the Americans seemed almost untethered, their positions resilient, their power uninterrupted. The significance of this disparity extended beyond mere convenience. Electricity powered radios, enabling coordinated strikes and early warnings. It illuminated runways for aircraft landings in darkness. It purified water, preventing disease. It allowed field hospitals to operate efficiently. Each kilowatt of electricity translated directly into combat readiness, health, and the ability to respond quickly to Japanese maneuvers. Japanese engineers were keenly aware of these advantages and began documenting them with a mixture of admiration and unease. In retrospect, the Pacific Islands had become laboratories for a new form of logistical warfare. The ability to generate portable, reliable power was not a minor technical detail. It was a force multiplier, a quiet yet decisive factor that shaped the outcomes of battles and campaigns. And while Japanese engineers were skilled, they were increasingly outmatched in this domain. The generators they observed in abandoned American bases were more than machines. They were a tangible symbol of an industrial and tactical philosophy that the Japanese had yet to fully counter. This growing awareness would set the stage for the Japanese realization that no amount of improvisation could match the Americans' systematic approach. They were about to confront the operational consequences of this technological advantage in ways that would leave a lasting impression on engineers, commanders, and soldiers alike. By mid-1942, the United States had fully committed to the Pacific theater, not just with troops and ships, but with a sophisticated logistical framework designed to overcome the vast distances and harsh environments of the islands. Central to this strategy was the use of portable generators. The U.S. Army and Navy collaborated with industrial manufacturers to produce compact units capable of delivering between 1.5 to 3 kilowatts of reliable power. These machines were rugged, standardized, and designed for rapid deployment. Soldiers could unpack, set up, and operate them within minutes, a stark contrast to the elaborate and often temperamental systems the Japanese had relied upon. Transportability was a key consideration. On islands without developed ports, generators were airdropped, ferried in landing craft, or carried on small trucks along hastily constructed tracks. Each unit weighed less than 200 kilograms, yet could run continuously for 8 to 12 hours on a single tank of fuel. Fuel itself could be stored safely in collapsible cans, reducing vulnerability to enemy attack or environmental hazards. In addition, engineers designed modular components that could be replaced or repaired on-site, often using simple tools carried in soldiers' kits. For Japanese engineers, accustomed to stationary, high-maintenance engines, the simplicity of these systems was both impressive and alarming. Once operational, portable generators transformed American bases, lighting illuminated landing zones, making nighttime aircraft operations possible. Water pumps ensured clean water supplies, drastically reducing disease and improving morale. Radios and signal equipment maintained constant communication between units, allowing rapid coordination of air, land, and naval forces. Medical units could operate with electric sterilization and refrigeration, enhancing casualty survival rates. For soldiers enduring the harsh conditions of tropical warfare, electricity was no longer a luxury, it was a lifeline. The impact of portable power became evident during the Guadalcanal campaign. U.S. engineers established functional bases within days of landing, providing electricity for hospitals, kitchens, and field offices. Meanwhile, Japanese engineers struggled to maintain the aging diesel generators left behind by retreating forces, many of which had suffered from salt corrosion or inadequate maintenance. Batteries depleted quickly, radios fell silent, and field hospitals relied on primitive lighting, often only lanterns or torches. The contrast was stark, and Japanese reports reflected a growing frustration. American bases seemed almost self-sufficient, capable of sustaining operations indefinitely, while Japanese facilities were increasingly fragile and vulnerable. Japanese engineers documented their observations meticulously. They noted the reliability of the generators, the ease with which Americans could repair them, and their ability to function in extreme conditions. They recorded surprise at the low failure rates, even in the oppressive heat and constant rain of the islands. Some engineers speculated on the fuel efficiency and longevity of these machines, while others focused on the organizational implications. The Americans were able to power not just one system, but an entire network of operations simultaneously, a feat the Japanese had previously believed impossible in the field. Beyond the immediate tactical advantages, portable generators reflected a broader strategic philosophy. American forces approached logistics not as a supporting function, but as a core component of combat power. By contrast, Japanese engineering, while innovative, often emphasized improvisation and individual ingenuity. Where Americans built for redundancy and scalability, Japanese solutions were site-specific and constrained by available materials. The generators became symbols of this philosophical divide. In every humming unit, Japanese engineers saw evidence of an industrial and operational discipline that could outlast improvisation, outlast attrition, and outlast the harshness of the Pacific environment. By the time Japanese forces faced these devices in multiple theaters, New Guinea, the Solomons, and later the Marianas, the impact was undeniable. Bases powered by portable generators maintained higher operational tempo, coordinated airstrikes more effectively, and sustained troop morale far longer than comparable Japanese positions. Engineers observing these developments recognized a stark reality. American industrial capacity, coupled with a philosophy of reliable, portable power, provided an advantage that could not be matched by ingenuity alone. This growing understanding would shape Japanese tactical and strategic planning in the months to come. Portable generators were not just machines. They were catalysts for change, tools that allowed Americans to project force farther, faster, and more consistently than ever before. For the Japanese engineers confronting these realities, the discovery of each new American base was a reminder. Their assumptions about the limitations of Allied logistics had been profoundly underestimated. And from this realization, the story naturally moves to the multiple angles through which this advantage affected the war: tactical, human, technological, and psychological. The perspectives that reveal why a seemingly small machine could alter the course of campaigns. Angle 1. Tactical advantage of reliable power. On the battlefields of the Pacific, every hour counted. American commanders recognized that a steady source of electricity could reshape tactical possibilities. Portable generators powered radios that connected forward units to naval and air support hundreds of miles away. Messages that once took hours or days could now be transmitted instantly, allowing artillery to adjust fire, aircraft to intercept enemy movements, and commanders to respond to threats in real time. Lighting provided another tactical edge. Runways illuminated at night allowed aircraft to land safely and conduct night missions that Japanese forces had assumed were impossible. Soldiers moving under the cover of darkness could navigate with confidence, supply drops could be recovered efficiently, and perimeter security became more effective. Even simple illumination in bivouacs improved alertness and reduced accidents, directly contributing to combat readiness. Japanese engineers, upon observing these setups, were astonished. They had anticipated American logistical shortcomings, but now confronted a force operating independently of terrain or infrastructure limitations. Generators created a form of tactical elasticity, enabling Americans to strike withdraw, and resupply with a consistency that Japanese commanders could not match. Small, portable, and efficient, these machines extended the reach of every soldier, every pilot, and every commander. In practical terms, a single generator could amplify the combat effectiveness of an entire unit, turning an ordinary base into a hub of operational superiority. Angle 2. Human impact, soldiers, medics, and communication crews. Electricity on the front lines was more than a tactical tool. It was a lifeline. Field hospitals, powered by portable generators, could sterilize instruments, preserve medicines, and provide light for nighttime surgeries. Soldiers recovering from injuries could rest in lit quarters rather than darkness, improving morale and survival rates. Water purification systems ensured clean drinking water, preventing the spread of disease that had claimed more lives than bullets in many Pacific campaigns. Communication teams thrived in this environment. Radios, telephones, and signal lamps functioned reliably, allowing troops to coordinate operations across complex island terrain. Messages were accurate, fast, and continuous, vital in situations where one miscommunication could cost dozens of lives. For medics, engineers, and line soldiers alike, electricity was a constant, almost invisible companion that enhanced efficiency, safety, and confidence. Japanese engineers studying captured bases recorded these human benefits with a mix of curiosity and apprehension. They noted how soldiers moved with assurance, how hospitals operated beyond what they had thought possible, and how the overall rhythm of American bases contrasted sharply with the makeshift improvisation typical of Japanese positions. Each observation reinforced the perception that portable generators were not just machines, but instruments that amplified human capability. Angle 3. Engineering perspective, design, durability, and simplicity. From an engineering standpoint, the portable generators represented a blend of simplicity and resilience. Components were standardized, allowing easy replacement and repair in the field. Engines were air-cooled or equipped with corrosion-resistant parts, able to withstand tropical humidity and salt air without frequent maintenance. Fuel efficiency was optimized, giving each unit extended operational time without cumbersome refueling. Japanese engineers, trained in meticulous design and complex machinery, were struck by the contrast. Whereas Japanese field equipment often required specialized tools and trained technicians, American generators could be maintained by any competent soldier. The durability, portability, and redundancy built into these systems reflected a deliberate philosophy, designed for reliability under extreme conditions. Captured units demonstrated to Japanese observers that American engineers prioritized operational continuity over theoretical sophistication, a subtle but profound difference in approach. This perspective also highlighted the industrial gap between the two nations. The ability to mass-produce dependable, portable machinery gave Americans an advantage that Japanese ingenuity alone could not match. Even in small units, generators represented a microcosm of America's broader industrial power, scalable, standardized, and resilient, quietly reshaping the battlefield before the first shot was fired. Angle 4. Enemy perspective, Japanese analysis and reports. Japanese engineers and intelligence officers documented their encounters with American portable power extensively. Captured generators, photographs, and technical diagrams were analyzed in attempts to replicate the designs. Reports emphasized surprise at the compact size, durability, and operational consistency. Some noted that a single generator could power more devices than entire Japanese positions could maintain. These analyses were tinged with a growing sense of alarm. Engineers recognized that the Americans could build operational bases almost anywhere, sustain them indefinitely, and maintain communication and medical infrastructure under conditions that had consistently crippled Japanese operations. The reports conveyed admiration, frustration, and unease, a tacit acknowledgement that the enemy had solved a problem the Japanese had struggled with for years. This perspective also revealed Japanese strategic concerns. Beyond individual bases, the implications were clear. Portable generators allowed Americans to project force farther, faster, and with a level of reliability that Japanese planners had underestimated. 4 engineers tasked with studying and countering Allied methods. Each discovery underscored a sobering reality. Technological innovation and industrial capacity could decisively shift the balance of power in the Pacific. Angle 5. Transformation of base life, lighting, cooking, and safety. Electricity reshaped daily life on American bases in the Pacific. Generators powered lighting that extended work hours far beyond natural daylight, allowing engineers to repair airstrips, stockpile supplies, and maintain security through the night. Kitchens equipped with electric stoves could prepare meals more efficiently, feeding hundreds of soldiers without interruption. Water pumps ensured clean water for drinking, sanitation, and cooking, drastically reducing the risk of disease that had historically plagued tropical deployments. Japanese engineers observed with growing unease. In previously captured bases, they had struggled to maintain functional lighting and water systems. Improvisation was the rule, not the exception. The Americans' ability to maintain operational normalcy under harsh conditions contrasted sharply with Japanese reliance on makeshift solutions, often vulnerable to weather or mechanical failure. Every powered facility became a hub of efficiency, a center of control, and a symbol of resilience that Japanese engineers could neither ignore nor easily replicate. The impact on morale was profound. Soldiers could rest, work, and operate in relatively normal conditions even amid combat zones. Safe lighting reduced accidents, reliable water prevented illness, and functional kitchens meant soldiers could focus on combat readiness rather than survival. To Japanese engineers, the generators were more than machines. They were instruments that extended the human capacity of every American unit on the islands. Angle 6. Psychological impact on Japanese troops. The discovery of powered American bases had a profound psychological effect on Japanese soldiers and engineers. Encountering these operational hubs, Japanese troops often expressed disbelief at how a relatively small force could maintain such high efficiency. Reports noted a sense of intimidation and frustration. No matter how many defensive positions were constructed, the Americans always seemed to have lights, water, and communications when the Japanese did not. Engineers, in particular, were unnerved. They recognized that the American reliance on standardized, portable, and durable power systems removed many traditional tactical vulnerabilities. Where Japanese forces expected to exploit isolation, scarcity, or environmental hardship, the Americans had neutralized these advantages. This led to a creeping sense of inevitability. The war was not only being fought with weapons, but also with unseen, relentless infrastructure. Psychological studies from post-war reports confirm this effect. Soldiers facing well-powered bases perceive the enemy as better prepared, more resilient, and harder to dislodge. Even small engagements often carried the weight of this perception. For Japanese planners, the realization that portable generators contributed to both tactical effectiveness and psychological superiority forced reconsideration of both strategy and morale management. Angle 7. Logistical philosophy, industrial capacity versus improvisation. At its core, the generator reflected a broader divergence in military philosophy. American operations emphasized industrial capacity, planning, and redundancy. Engineers designed systems to be simple, durable, and easily transported. Parts could be swapped out in the field, fuel could be stored efficiently, and bases could operate autonomously for weeks at a time. Japanese forces, while highly innovative, often relied on improvisation, local materials, and ingenuity. Their systems were adaptable but fragile, highly dependent on local resources and expert maintenance. The contrast was stark when Japanese engineers encountered portable American generators, a small, robust machine that could maintain operational capability far longer than any equivalent Japanese installation. This difference extended beyond technology into strategic doctrine. While the Japanese optimized for tactical efficiency, the Americans optimized for sustained operational reach. Portable generators symbolized this philosophy. Every base could be powered, every operation could be sustained, and every logistical bottleneck mitigated. For Japanese engineers and commanders, the realization was unavoidable. Industrial capacity, combined with careful design, had turned even small American units into self-sufficient, resilient forces. The full implications of this logistical advantage would emerge in the next phase of the war, when Japanese forces were forced to confront the reality of American bases operating at full strength while their own infrastructure faltered. This understanding naturally leads into the climax/turning point, where the decisive moments of generator-enabled operations become clear. August 1942, Guadalcanal. The island's jungles were thick with humidity, the air heavy with the scent of salt, rotting vegetation, and the smoke of distant shell fire. American forces had landed weeks earlier, establishing a tenuous foothold near Henderson Field. The Japanese, determined to dislodge them, were preparing to strike. Engineers, both American and Japanese, worked tirelessly, one to maintain power, the other to understand and ultimately counter it. At the heart of the American perimeter, portable generators hummed steadily, feeding electricity to radios, lighting, and water pumps. In tents and makeshift shelters, signal officers transmitted vital information about troop movements, enemy patrols, and impending air raids. Each message flowed seamlessly from field unit to command ship, often arriving hours before Japanese intelligence could even confirm positions. 4 Japanese engineers secretly observing from the edge of the jungle. It was a revelation. Reports from captured engineers later detailed their astonishment. A single generator could power a field hospital, a radio station, and an airstrip simultaneously, maintaining operations through nights of torrential rain and tropical storms. Diesel engines in Japanese positions, by contrast, were temperamental, prone to flooding, and incapable of sustaining continuous operation. The Americans' ability to maintain uninterrupted power gave them a tactical rhythm and operational flexibility the Japanese had never encountered. The decisive moment came during a night raid on Henderson Field. Japanese forces had planned to sabotage the airstrip, believing that darkness and isolation would favor their attack. But the American base was fully lit, radioed in advance for reinforcements, and coordinated air patrols that intercepted the attackers. Engineers observing the aftermath noted with disbelief that the Americans' technological edge, enabled by portable generators, had turned what should have been a surprise attack into a repelled assault. Casualty reports confirmed the disparity. Japanese losses were significant, while American operational capability remained intact. Beyond the immediate battle, the implications of portable power became evident in every skirmish on the island. Artillery positions received coordinated updates, medical teams operated without interruption, and supply lines continued unbroken. Each generator was a small node of control, multiplying the effectiveness of men and machinery alike. Japanese engineers recorded their frustration. No improvisation, ingenuity, or local adaptation could replicate this operational continuity. The enemy was always one step ahead, not because of superior numbers or courage, but because of the unseen, humming machines that ensured everything else functioned flawlessly. By late August, captured Japanese notes and photographs reflected a growing acknowledgement. These generators were not merely tools. They were force multipliers. Engineers documented their internal calculations, attempting to estimate fuel consumption, output, and reliability. Even those with considerable technical expertise admitted that replication under wartime conditions would be nearly impossible. The Americans had effectively decoupled operations from the limitations of terrain, weather, and supply vulnerability. The night sky over Guadalcanal bore witness to a subtle but decisive shift in the battle. While Japanese forces had moved through the jungle with the expectation of disrupting and undermining the Americans, they instead encountered a networked, resilient force, powered continuously and coordinated flawlessly. portable generators, small and unassuming, had created a chain of operational advantage, tipping the balance in favor of the Allies. This moment marked the broader turning point in the Pacific Logistics War. It was no longer simply about who held the airfield, the hill, or the coastline. It was about who could sustain operations in the harshest environments, maintain readiness through night and storm, and project force reliably over long distances. The Japanese engineers' stunned realization that a single piece of equipment could so fundamentally alter the operational landscape underscored the quiet, transformative power of American logistical innovation. By dawn, the jungle was silent except for the hum of the generators. Japanese engineers retreated, notebooks in hand, each line documenting not only what they had seen, but also what they had failed to achieve. The Americans, largely unaware of the psychological impact, continued their operations, their bases alive with the subtle, constant pulse of electricity, a pulse that had changed the calculus of warfare in the Pacific. The stage was set for the continuation of this advantage across multiple islands, as portable generators enabled the Americans to extend their reach, maintain supply lines, and coordinate attacks with precision. This understanding naturally transitions into climax, Section 2, where the full operational consequences of portable power are revealed in subsequent campaigns. By early 1943, the significance of portable generators had expanded beyond Guadalcanal. American forces, having learned from early island campaigns, systematically integrated these machines into every new base on the Solomon Islands, New Guinea, and later the Mariana Islands. Generators powered communications, airfields, and medical units, enabling a continuous operational tempo that Japanese forces could neither match nor anticipate. At Buna and Gunna in New Guinea, Japanese engineers were confronted again with the practical advantages of portable power. American units arrived in inhospitable terrain, swamps, dense jungle, and mountainous ridges, and within days had functional camps. Radios connected infantry, artillery, and naval support. Hospitals operated at full capacity. Airstrips were leveled and illuminated for night landings. The hum of generators was the pulse of a well-oiled machine, each kilowatt extending the reach of the Allied force. Japanese soldiers, accustomed to operating in makeshift, often powerless positions, were demoralized by this contrast. Captured reports detail engineers' frustration and amazement. They noted how the Americans' use of small, mobile generators enabled forces to project power deep inland, independent of traditional supply chains. Engineers speculated on fuel efficiency, maintenance schedules, and output consistency, often concluding that replication in situ would be impossible without an industrial base of comparable scale. These assessments highlighted a profound disparity. The Japanese had relied on ingenuity to overcome logistical obstacles, while the Americans had effectively removed the obstacles themselves through preparation and innovation. The operational consequences were stark. Coordinated artillery fire could be sustained longer. Night reconnaissance and bombing raids were conducted reliably. Medical teams could handle higher casualty volumes without interruption. Even minor logistical tasks, pumping water, charging batteries, lighting field kitchens, took on strategic significance because they allowed combat units to operate continuously. Every generator became a hub of efficiency, amplifying human and mechanical performance across the theater. In the Marianas Campaign of 1944, the advantage became fully apparent. Islands previously considered too remote or difficult for sustained operations were now fully supported. American engineers deployed generators alongside prefabricated buildings, water purification units, and modular communication hubs. Bases could remain operational for weeks without resupply, allowing aircraft and naval forces to maintain pressure on Japanese positions. Japanese engineers observing captured or abandoned American positions recorded their astonishment. What had once seemed a simple support function now dictated the pace and scale of combat operations. Even beyond physical infrastructure, portable generators reshaped the tempo of the war. Japanese planners realized that attritional strategies, starving the enemy of power, communications, or supply, were less effective against an opponent who could establish self-sufficient bases within days. Each generator, small in size but vast in consequence, allowed the Americans to bypass traditional vulnerabilities and maintain initiative across the Pacific. Engineers' notes reveal repeated use of the term incomprehensible, reflecting both technical admiration and operational anxiety. The human dimension was equally critical. Soldiers working in powered bases experienced higher morale and efficiency, while Japanese forces faced constant pressure and uncertainty. The Americans' ability to operate night and day, to repair equipment, and to sustain medical and communication facilities created a psychological advantage that compounded their material one. Engineers and intelligence officers recognized that portable generators were not simply tools, but instruments that magnified every aspect of combat capability, from planning and execution to morale and resilience. By mid-1944, the narrative was clear. Portable generators had transitioned from a minor logistical convenience to a decisive factor in the Pacific Campaign. Battles were influenced not just by weapons or numbers, but by the presence of reliable, mobile power. The Japanese engineers' stunned realization that a small, transportable machine could alter operational effectiveness so dramatically marked a turning point in both tactical and strategic understanding. This climactic phase demonstrated that warfare in the Pacific was as much a contest of infrastructure and ingenuity as it was of firepower. Portable generators were the quiet arbiters of this contest, enabling the Americans to strike swiftly, sustain pressure, and maintain a tempo that Japanese forces could rarely match. Every operational success traced back, in part, to the hum of a machine capable of powering radios, lights, hospitals, and airstrips under the harshest conditions. The lessons of Guadalcanal, Buna, and the Marianas set the stage for the aftermath, with the broader consequences of this technological advantage on strategy, morale, and campaign outcomes would become fully evident. By late 1944, the cumulative impact of portable generators on the Pacific Campaign had become undeniable. The Americans had demonstrated an ability to project power into remote, previously inhospitable islands, sustaining operations far longer than Japanese forces had anticipated. Guadalcanal had been the first visible example, but subsequent campaigns, New Guinea, the Solomons, and the Marianas, confirmed that a single small, reliable machine could influence the outcome of entire operations. Japanese engineers' reports from captured or abandoned bases repeatedly emphasized the disparity. They noted that generators allowed American bases to maintain continuous communications, coordinate airstrikes, and supply field hospitals with near-constant efficiency. These advantages translated directly into combat outcomes. Japanese troops, often isolated on poorly powered bases, faced difficulties in receiving timely intelligence, conducting repairs, and maintaining morale. In contrast, American units, connected through a network of power communications and infrastructure, could respond rapidly to threats and sustain prolonged offensive operations. Beyond tactical considerations, the generators reinforced a broader strategic philosophy. American forces treated logistics and infrastructure as integral to operational planning, rather than as supporting elements. Portable generators were emblematic of this mindset, ensuring that bases could operate independently of traditional power sources. Engineers in the field could maintain operations despite tropical storms, damaged equipment, or limited local resources. Every powered base became a hub of efficiency, allowing American commanders to concentrate on strategic objectives rather than improvising solutions to basic operational problems. The psychological dimension of this advantage cannot be overstated. Japanese soldiers encountering well-powered American positions were often demoralized, recognizing that their own improvisational solutions could not match the operational resilience of the Allied forces. Engineers documented instances where troops abandoned planned assaults after discovering fully lit, fully operational enemy bases. The generators became symbols of American dominance, not in sheer firepower alone, but in the capacity to sustain and coordinate combat operations under conditions that had previously favored the defender. At the operational level, the effect was cumulative. Bases powered by portable generators enabled nighttime operations, rapid deployment of air and naval assets, and continuous medical and logistical support. These capabilities amplified the impact of every soldier, pilot, and vehicle, creating a multiplier effect that magnified the effectiveness of American forces. Japanese engineers noted that no single battlefield encounter could fully capture the advantage conferred by portable power. It was a sustained operational rhythm, maintained over weeks and months, that proved decisive. This recognition shaped Japanese strategic planning in subsequent campaigns. Reports stressed the need to capture or destroy American generators, or at least to anticipate the operational reach that powered bases allowed. Yet the Americans' industrial capacity and standardization meant that even when units were lost or damaged, replacements could be deployed swiftly. Japanese engineers acknowledged that while ingenuity and improvisation could address isolated problems, they could not replicate the scale and reliability of American logistical systems. In sum, by the end of 1944, portable generators had shifted the operational landscape of the Pacific War. They were small, seemingly mundane machines, yet their influence extended to communications, medical care, tactical coordination, morale, and strategy. Japanese engineers and commanders alike recognized that these devices represented not only technological superiority, but also a fundamentally different approach to sustaining military power. The stage was set for a deeper understanding of the full consequences, how portable generators would influence campaigns, force reallocations, and ultimately the psychological and material balance between the Allies and Japan. The story now naturally moves to Aftermath, Section 2, where these longer-term consequences are examined in detail. As 1945 approached, the operational advantages provided by portable generators had become deeply embedded in the U.S. military strategy across the Pacific. By the time of the Mariana and Palau campaigns, American bases were no longer temporary encampments. They were fully functional, self-sustaining hubs. Engineers deployed prefabricated structures, water purification systems, communication networks, and, crucially, generators. These bases supported complex operations, from large-scale amphibious assaults to coordinated aerial bombing runs. Each kilowatt produced by a generator extended the reach and endurance of U.S. forces, ensuring they remained operational in environments that had historically hampered military campaigns. Japanese engineers continued to study these systems, often in the aftermath of retreating or abandoned positions. Their reports emphasized the impossibility of duplicating such capabilities without a comparable industrial base. Even where they captured American generators, the Japanese could not maintain them long enough to replicate the advantages they had observed. The efficiency, reliability, and portability of these machines underscored a growing recognition. American logistics were as formidable a weapon as artillery or aircraft. Portable generators had transformed the nature of the campaign, allowing sustained operations far from established supply chains. The psychological impact on Japanese troops and commanders was equally significant. Encountering well-lit, fully operational American positions repeatedly undermined confidence. Night raids, once expected to yield surprise, became increasingly risky as American bases could coordinate defenses with uninterrupted communication and maintain continuous surveillance. Engineers noted that Japanese morale often declined after observing American operational resilience, a testament to the intangible but decisive effect of powered infrastructure. On the Allied side, the results were unmistakable. Bases with reliable electricity allowed for efficient medical care, ensuring fewer casualties succumbed to disease or untreated injuries. Communications networks enabled precise coordination of naval and air forces, increasing the effectiveness of strikes and reducing friendly fire incidents. Soldiers and engineers could work longer hours safely, maintain equipment, and respond dynamically to battlefield developments. Portable generators created an operational tempo that Japanese forces struggled to counter, effectively dictating the rhythm of the campaign. The broader strategic implications were equally profound. Portable generators exemplified a military philosophy rooted in preparation, industrial capacity, and sustainability. Where Japanese engineering emphasized ingenuity within constraints, American logistics removed those constraints entirely, allowing forces to operate at maximum efficiency regardless of terrain or weather. This difference contributed directly to the success of operations across the Pacific, accelerating the pace of island-hopping campaigns and diminishing the effectiveness of Japanese defensive measures. By the conclusion of these campaigns, the cumulative effect of portable power had reshaped both tactical and strategic calculations. Japanese forces recognized the limits of improvisation against an opponent who could sustain, coordinate, and adapt far more effectively. Reports repeatedly emphasized that the Americans' logistical sophistication, symbolized by small, resilient generators, represented a decisive, though often invisible, force multiplier. These lessons would carry into post-war analyses. Historians and military engineers acknowledged that portable generators, while seemingly minor components of a vast war machine, had fundamentally altered the dynamics of the Pacific conflict. They enabled continuous operations, amplified human effort, and provided a strategic advantage that extended beyond any single battlefield. The generators were, in many ways, the quiet arbiters of victory, demonstrating how infrastructure and preparation could outweigh numbers, terrain, or even raw bravery. From a hum of a generator in a jungle clearing to the coordinated airstrikes and resupplied front lines it enabled, the story of portable power reveals the interplay between technology, human effort, and strategy. The stage is now set for the final, reflective examination of what this innovation meant for warfare, history, and the human experience in the Pacific. Portable generators in the Pacific were small, unassuming machines, yet their impact rippled across every battlefield, base, and operation. They embodied a philosophy that transformed warfare, that infrastructure, preparation, and reliable technology could become as decisive as soldiers or artillery. In the humid jungles of Guadalcanal, the swamps of New Guinea, and the volcanic shores of the Marianas, the steady hum of these engines powered not only equipment, but also strategy, morale, and the tempo of war itself. For Japanese engineers, the generators were a revelation. They represented a level of foresight and industrial capacity that could not be matched by improvisation or ingenuity alone. Every well-lit airstrip, every operational field hospital, every connected radio network was a testament to meticulous planning and engineering discipline. The hum of a generator was the quiet heartbeat of a force capable of sustaining itself where others faltered, extending the reach of men and machines alike. Beyond the immediate battlefield, the story of portable power offers a broader lesson about the nature of warfare. Victory is rarely determined solely by courage or numbers. It often depends on the unseen mechanisms that allow forces to endure, communicate, and adapt under extreme conditions. In this sense, generators were both literal and symbolic. They powered devices, yes, but they also powered operations, human effort, and the capacity to maintain initiative in hostile environments. Today, the legacy of these machines endures in military logistics, engineering, and planning. Modern forces continue to rely on portable, reliable systems that sustain operations far from infrastructure, echoing the lessons learned in the Pacific theater. The generators remind us that innovation is not measured by size or spectacle, but by its ability to enable human potential and shape outcomes in ways that are at once practical, psychological, and strategic. In the end, the story of America's portable generators is a story of quiet dominance, of power harnessed efficiently, of preparation realized in metal and hum, and of a small innovation that, in the hands of organized industry, helped turn the tide of a global conflict. The engineers who first encountered these machines may have been stunned, but history would recognize their significance long after the battles had ended.